Bismillahirrahmanirrahim. How are you, students? Today we will study Newton third law. Lecture number 19, subject physics, page 55. But before going into detail of Newton third law, we will explain difference between mass and weight. Mass and weight. So comes towards the difference. You in class 7th you already studied mass and weight. You know a little bit about mass and weight. Now first, mass is the amount of matter in an object. Mass can be defined as the amount of matter in an object. For example, if your mass is 55 kg, on moon surface your mass will remain same. Everywhere you go your mass will remain same. But weight is the push or pull of earth, the force with which the earth attracts. The force with the force with which the earth attract an object. The force of attraction of an earth on an object due to the pull of gravity on a body. The earth attractive force. His mass is a scalar quantity. Weight is a vector quantity. The unit mass is measured in kilogram. If you write mass, you will write 25 kg, 50 kg, you will write kg. And weight is measured in Newton. Constantly, regardless of the gravitational field strength. It is independent of Earth gravity. It does not depend on Earth gravitational force. Varies according to the strength of the gravitational field. If you go higher, weight will decrease because the gravitational force decrease. Usually measured by a beam balance. Usually measured by spring balance. Weight is measured by spring balance. Mass is measured by beam balance or physical balance. Physical balance. Weight is derived quantity. Mass is base quantity. Now next is measured in kilogram. You already studied, is always remains the same, closely related with inertia. Mass is a measure of the inertia. Cannot be measured directly. Measured in newtons, can change with change in location, closely related, can be measured by direct scale. Now this is the formula for weight. Weight is equal to mg, where weight is the force and it is a vector quantity. SI unit is Newton. It is measured by spring balance. Weight is the force with which the earth attracts a body. Earth attractive force on an object. Earth attractive force on an object. Now Newton third law. Newton third law states that for every action there is an equal but opposite reaction. But opposite reaction. A force is interaction between one object and another. For example, the interaction between a hammer and a nail. A A hammer exerts a force on a nail and drives it into a board, and a nail exerts a force on a hammer. Newton third law. When one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. A balloon push pushes escaping air down. Balloon push air in downward direction. As a result, the balloon move in the upward direction. The ejection of air from the balloon is action, and as a reaction, the balloon will move in the upward direction. Now, on this ball, if it is pushed downward, it exerts the ball exerts the force on the wall is the action, and the force of the wall on the ball is the reaction. This is the ejection of fuels is the action. As a reaction, the rocket will move in the upward direction. Air is is move is ejected from the balloon as a action, and as a reaction, the balloon will move in the upward direction. The force exerted by the finger on the wall is action, and the wall exerts the reaction force. Newton laws of motion. In first law, every object will consist of two states. That if an object is in rest, it will continue its state of rest, and if it is moving with uniform speed, it will continue its state of motion if no external force acts on the system. And in second law, acceleration is directly proportional to the force, and acceleration is inversely proportional to the mass of an object. In third law, every action has a reaction. For every action, there is an equal but opposite reaction. Now, momentum. We already explained in the lecture number 18 that momentum is that property which increase with increase in mass as well as velocity, and decrease with decrease in mass as well as velocity. As we know that F is equal to ma. This is from Newton's second law. Newton's second law. And we know that force, mass, and in place of acceleration you will write A is equal to, by definition of acceleration, del v divided by del t. It is the equivalency of acceleration. We write the value of acceleration this by definition of acceleration. Now F is equal to, we have written m, and in place of del v we will write vf minus vi divided by del t. Del v is equal to vf minus vi. So in place of del v we will write m vf minus vi divided by del t. So m is multiplied with vf, we will get m vf minus m vi, we will write divided by del t. So as we know that momentum is equal to this, so going to next page. Now P is equal to mv, so pi mvi, pf is equal to mvf, so f is equal to m vf minus m vi divided by del t. So f is equal to m, this is equal to pf minus pi. Pf means final momentum, pi means initial momentum, so del p divided by del t. So f is equal to del p divided by del t, where del p is equal to the difference between final momentum and initial momentum. Now this is difference between final momentum and initial momentum. So from this we can define force as del p divided by del t. The change in momentum with respect to time is called force. So rate of change of momentum, rate of, I will erase, F is equal to del p divided by del t. Force can be defined as the rate of change of momentum. The rate of change of momentum is called force. Now, what are the unit of momentum? Unit of mass is kilogram. The unit of velocity is meter per second. So kilogram meter per second is the unit of momentum. Now kilogram meter per second is the unit of momentum. Write it, kilogram meter per second. As we know that the unit of momentum is kilogram meter per second, so we have to express it in a term of unit of force. So kilogram meter per second can be written like this. So here it is multiplied with second and divided with second. So here we can write, so it can be written as kilogram meter per second square, and here you will write second. As we know that F is equal to ma, so here we can write 1 Newton is equal to 1 kilogram meter per second square. So here we will write Newton second. This is equal to Newton. So the unit of the unit of momentum is kilogram meter per second, which is equal to Newton second. Now the next topic is law of conservation of momentum. Law of conservation of momentum, which said that the total momentum before a collision is equal to the total momentum after the collision if no external force act on the system. So momentum before collision, momentum before collision is equal to momentum after collision. After collision, this result is true for all collision between any objects, a car and a truck, two railroads cars. It is for head-on collision. Head-on collision. Now first is, let consider the given example. This is body having mass m1 and velocity u1. So it is before collision. So momentum is p1 and it is equal to m1 u1. Its momentum before collision is p2 and is equal to m2 u2. Here collision take place, mass remains constant during collision, velocity changes. So the momentum of first particle changes because its velocity changes. So m1 v1, it's p1 prime. Similarly p2 prime is equal to m2 v2 prime. So according to the law of conservation of momentum, momentum before collision, momentum before collision is equal to P1 plus P2. This is before collision. So write M1 U1 plus M2 U2. It is before collision. Now I will write momentum after collision. Momentum after collision. After collision is equal to P1 prime plus P2 prime. Now according to law of conservation of momentum before collision is P1 plus P2 is equal to after collision P1 prime plus P2 prime, and it can be written as M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, M1 U1 plus minus M1 V1. This is transferred to this side. M2 V2 minus M2 U2. This is transferred to the other side. M1 is common. U1 minus V1 is equal to M2 V2 minus U2, which is law of conservation of momentum. Now this is from Newton's third law. We derive the same statement that which is derived I have derived for you people. Which one of the object exerts a force on other object? The other objects also exerts an equal but opposite force. Means action and reaction are always equal but opposite in direction. As a reaction, this is a negative sign. So according to definition of force, which we derived for relation between momentum and the rate of change of momentum is called force, which we already derived. According to that relation, if is equal to this, can be written as m del v divided by del t. So t is cancelled on both sides. M1 v1 minus u1. It is the final velocity of first particle and it is the initial velocity. Final velocity and initial velocity. So this statement should be written like this with a negative sign because of reaction. M1 U1 M1 is multiplied with this and M1 is multiplied with this. M2 is multiplied with V2 and with U2. So you will get this statement. This is negative, so transfer to that side. It should be kept on the same side, and it will also be kept on the same side. M1 V1, M2 V2. This this will become like this. This is transferred to this side, that the negative sign will become positive. So we will get this after simplification. Final momentum of the two objects, original momentum of the two objects. It is the initial momentum of first particle. It is the initial momentum of the second particle before collision. It is the momentum after collision of the first particle. It is the momentum of first particle before collision, after collision. Now conservation of momentum of gun. So momentum at this state, the bullet is in state of rest, so velocity is 0, bullet velocity is 0. So momentum of bullet is 0 because momentum is the product of mass and velocity. So velocity is 0, momentum will be 0. Gun is also in state of rest, so momentum is 0 because gun velocity is v2 and is equal to 0. Now it recoils with in the when the bullet is fired from a gun, the gun recoil in the backward direction. Let the velocity of gun is bullet is v1 prime and that of gun is v2 prime, as v2, so change to v2 prime, v1 change to v1 prime. Now same example that I explained, according to law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the momentum of bullet. Bullet initially in state of rest, so we will write in place of this 0. Gun is also in state of rest, so gun velocity is also equal to 0, so 0 0 0 m1 v1 prime plus m2 v2 prime. So this equation can be written as minus m1 v1 prime is equal to m2 v2 prime. So the bullet velocity is v1, which will be equal to m2 v2 prime divided by m1, but with a negative sign. The gun velocity is equal to m1 v1 prime divided by v2 m2 is equal to m2. So similarly, the when you push the football in this direction as a reaction, it will move in the backward direction. So if the gun is fired, bullet is fired from a gun, the velocity of the bullet after firing will be v1 prime and will be equal to m2 v2 divided by m1, but with a negative sign. Similarly, velocity of gun after recoiling, after firing, is equal to m1 v1 divided by m2 with a negative sign. Now the next topic is friction. I will explain a little bit. What is friction? Friction is the opposition to the motion of the force which opposes the motion of the body. The force which opposes the motion of the body. Motion of the body or an other surface. For example, if you push this body in this direction, there is a ups and down. This surface will be will be not smooth. If you take a microscopic look, if you look at microscopically, this surface, both surfaces will be rough a little better, so it will oppose the motion. So when you push this in this direction, the contact points between these two surfaces will oppose the so an opposition act in the opposite direction. So the opposition to the motion of the body over the surface of another body is called friction. The opposing force which acts in the opposite direction of the movement of the upper body is called friction. For example, this body is moving in this direction. The force which acts in the opposite direction, which resists the motion of this body, is called friction. Friction is represented by small f, by small f, and it is the opposing force to the motion of the body. Now friction occurs whenever two surfaces rub against each other. Friction is a force that always opposes. Friction is self-adjusting force. Is a self-adjusting force. Friction is self-adjusting force. So if you increase the applied force, force of friction increases. Friction also increases. Force of friction is directly proportional to the weight of an object. Force of friction is directly proportional to the normal reaction. Weight is also represented by R, and R is also represented by Fn. So Fn normal force If N is the normal force represented by R, which means reaction, which means is equal to W. These are all same forces. So force of friction is directly proportional to the weight of the body. Force of friction is equal to mu K into R. Fn is equal to mu into W. This is right. This is also same equation. F is equal to normal force is equal to mu into Fn. All these relations mean the same thing. So force of friction is the opposition to the motion of the body. Now force of friction is equal to mu into Fn. Mu is equal to force of friction divided by F. Fn. So mu is coefficient of friction. So mu is the ratio, and ratio have no unit. Thank you, students. Further, in the next coming lecture, we will study different types of friction, and we also this theory of this chapter. In the third lecture, the theory of this chapter will be finished. Thank you, students. Wish you best of luck. Allah Hafiz.